This report explores the essential structural materials used in shipbuilding, focusing on their roles and ensuring a vessel's strength, stability, and longevity. It covers key components like the keel, hull plating, and internal supports, highlighting their material properties and dimension. 1. The keel is the main structural beam running along the bottom of the ship, crucial for stability and strength. Its dimension typically range from 1 to 2 meters wide and 0.5 to 1 meter high, depending on the size and type of the vessel. 2. Frames are vertical supports inside the hull, spaced regularly to keep the ship's shapes and strength. They are usually spaced about 0.5 to 1 meter apart. 3. Plating the ship's outer shell, enhancing hull strength. Thickness usually range from 50 to 30 mm. 4. Bulkheads vertical partition inside the ships that separate compartments and add structural strength. Thickness is generally 10 to 20 cm. 5. Deck beams horizontal supports running across the ship's rig to hold the decks in place, typically 20 to 50 cm in height. 6. Stringers are longitudinal beams placed along the hull of the boat or ships to enhance structural strength and rigidity. Typically, the width of stringers range from 10 to 50 cm. The height can vary depending on the specific design requirements of the vessel. 7. Stem and stern posts. These are vertical structural members at the front stem and the rear stern posts of a ship, providing shape and support. Their dimension vary based on the ship size. 8. Double bottom. This is a reinforced layer of plating at the hull's bottom for extra strength and protection. The thickness of the double bottom plating usually range from 15 to 30 mm. 9. Pillars. These are vertical support that carry loads from the ship's deck down to the hull. Their dimension vary with ship design but typically have a diameter of about 20 to 50 cm.
Deckhouse provides accommodation for the crew, including living spaces like cabins, mess rooms, bathrooms, and possibly the galley of the officers' quarters. Spars, horizontal poles that help support sails or other equipment attached to the mast. Its dimension is 10 to 30 meters long. Bulwark acts as a protective wall to prevent water from splashing over the deck. Its dimensions is 1 to 2 meters high.
4. Hatch combings. Raised edge around the deck hatches to prevent water from entering. Dimensions. Height usually range from 30 to 50 cm. 5. Skeg. An extension at the stern that support the rudder and enhance directional stability. Dimension. Varies with ship size. Typically extends several meters from the stern. Number 6. Bossing. Reinforcement around the propeller shaft to reduce turbulence and improve propulsion efficiency. Dimension. Extends several meters from the hull.
7. Garboard straight. This is the first row of hull plating adjacent to the keel, providing additional strength to the boat structure. It typically has a thickness of 15 to 30 mm. 8. Shear strain. This is the topmost row of hull plating, also designed to enhance the hull's strength. Its thickness is generally 15 to 30 mm as well. 9. Rudder. A movable component at the stem used for steering at the ship, usually several meters in height and width, with a thickness of 15 to 30 mm. 10. Bilge keel. A stabilizing feature along the hull to reduce rolling, typically 30 to 15 cm wide and extending several meters. 11. Transom. The flat or curved panel at the ship's rear that supports the rudder and propeller. generally 20 to 30 mm thick with variable width. 12. Tank top. The structural floor of the bottom of cargo holds, providing strength and protection, with a typical thickness of 15 to 30 mm. 13. Longitudinal. Long beams running parallel to the keel to provide additional support, typically 50 to 30.
Dimensions of ships. LOA or length overall. The length of ship affects its capability, stability, and speed. Longer ships, like modern container vessel, can exceed 400 meters, about 1,300 feet, and are designed to maximize cargo space and reduce transport costs. However, longer vessels can face challenges in maneuverability and docking, and their size can limit access to certain ports. Beam. The beam is critical for stability and cargo capacity. A wider beam increases the ship stability, allowing to carry more cargo or withstand drag seas better. For example, a large container ship with a beam of around 60 meters, about 200 feet, is more stable and can carry more containers compared to a narrower vessel. However, a wide beam can also impact in the ship's ability to pass through narrow seats or canals. Draft. Depth below waterline. The draft determines the minimum depth of water needed for a ship to float. Ships with a depth draft, such as large oil tankers, can carry more cargo but are restricted to deeper waters. Conversely, ships with a shallow draft can operate in shallower areas, making them suitable for rivers and coastal regions, but often with reduced cargo capacity. Height air draft. The height of a ship from the waterline to the top of superstructure impacts its ability to pass under bridge and through tunnels. For instance, the design of cruise ships often takes air draft into account to ensure they can navigate under bridge in popular cruising regions.